Hello and welcome to the Management Channel once again. This time we're going to talk about process strategy. Our objectives here is to look at the four process strategy types, to kind of learn about process analysis and design, learn how to use the tools of process analysis, a little bit about service design techniques, and examine customer interaction in the service processes. So what is the objective of a process strategy? It's to create a process to produce products that meet customer requirements or exceed, I'm going to add, within cost or other managerial constraints. How do we produce a product or service that meets or exceeds the customer requirements, meets cost and managerial goals, has a long-term effect on cost and quality, and is efficient while having production flexibility? First, you have to understand your process, and you need to create a flow chart of all the steps in the process. So a process flow diagram starts with the first step in the process, like here we have frame tube bending, and then moving over to machining and hot paint, and then over to the engine and transmission section. And from there, it follows this path all the way on through to making the final motorcycle. So you indicate each step of the process along the way. And then you crate it, ship it. There are four process strategies: a process focus, a repetitive focus, a product focus, and a mass customization focus. Process choice is demand driven. For instance, variety. How much is needed? Flexibility. To what degree do we need to be flexible? How much output do we need to produce? So, which is the best for the job? For low or very low volume, a job shop is recommended. For moderate volume, a batch process is recommended. For high volume, a repetitive process is recommended. And for very high volume, you want a continuous flow. Process focus is merely the production facility organized around processes to facilitate low volume, high variety production. Job shops are low volume, high variety. One example might be a surgery room. You have many input: surgery, sick patients, baby delivers, emergencies, and then it's routed to very different departments or off to surgery. Repetitive focus is a product-oriented production process that uses modules. Facilities often organized as assembly lines. It's characterized by modules with parts and assemblies made previously. Or the modules may be purchased from an outside supplier and brought into the facility. Modules may be combined for many output options. And unfortunately, it's less flexible than process-focused facilities, but it is more efficient. So a repetitive process is like an auto assembly line. You have all the raw materials and module inputs, different kinds of engine models, wheel modules, fender design, interior, and you produce an output of many options. This color car, that color car, this brand, that brand. Product focus is facilities are organized by the product. High volume, but a low variety of products. It's pretty much a long, continuous production that runs enabled efficient processes. Typically, there's a high fixed cost, but a low variable cost. And for this, we generally use less skilled labor. So a product focus might be like a low volume, high variety, continuous flow. For instance, Frito-Lay potato chips, different size bags, different size chips, barbecue, Ruffles. So you have a few inputs, but you produce a different amount of packaging: 3 ounce, 5 ounce, 24 ounce, etc. Mass customization is a rapid, low-cost production of goods and services to satisfy an increasingly unique customer desire. Combines the flexibility of a process focus, but with the efficiency of a product focus. So mass customization might be Dell computer. You have all kinds of inputs: chips, hard drives, software cases, etc. And they produce a variety of different outputs, different processor speeds, different graphic modules attached, and so forth. Customization is an imaginative and fast product design with a rapid process design and tightly controlled inventory management with very tight schedules. It's responsive to their supply chain partners. So, taking a look at process comparisons, you can see process focus, repetitive focus, product, and mass customization. Take a moment and look at this chart. If you need to pause, please do so. Focus processes is where the focus brings up efficiency. The focus on the depth of the product line rather than the breadth. Focus can be customers, a particular type, could be products, a variety of different steel, stainless steel, cast iron. It could be service like children's hospital or a walk-in clinic. Technology could differ by software or hardware. Selection of equipment is done by decision making, which could be complex as alternate methods may be available. Important factors are cost, your cash flow, what is the market stability, can you afford to buy this new equipment, what's the quality expected, what is your capacity, and what is your flexibility to be able to change. When analyzing and designing, we have to ask, first of all, is the process designed to achieve a competitive advantage? Does the process eliminate steps that don't add value? Do we get rid of the non-value added steps in the process? Does the process maximize the customer value? And will the process win new orders? So we want to have a flow chart. It's a schematic or drawing of the movement of material, product, or people. So as you can see, the example, we have customers, final assembly. Over here is all the inputs from the suppliers, the different finishing lines or fab lines into a subassembly, and then finally into a final. So you want to draw a flow chart itemizing and depicting all the steps in the process from the raw materials down to the finished product. What is time functioning mapping? Well, it's a flow chart, much like you've seen, but only time added on the horizontal axis. This could be done like with value stream mapping. Value stream mapping is a process that helps managers understand how to add value in the flow of material and information through the entire production process. It extends from the customer all the way back to the suppliers. Here you see an example of it. And you notice down here in the bottom horizontal line, it says 5 days, and it also shows how many minutes or seconds it takes to produce each step of the process. So I'm going to leave this with you for a moment to study. You can see the customer makes an order, the supplier is notified, the parts come in, and we have daily communication on how to produce it and how long it should take. If you'd like to pause to see this longer, please feel free to do so. Value stream mapping is a very important aspect of lean operations. So you begin with symbols for the customer, the supplier, and the production to ensure that you have the whole entire picture. You enter the customer order requirements. You calculate the daily production requirements. You enter the outbound shipping requirements and delivery frequency. Determine the inbound shipping method and how often that comes. Add the process steps like machine, assembly, and sequence from left to right. And then you add communication methods, add their frequency, and show the direction with arrows. Notice that inventory quantities are depicted with an eye in a triangle between each step of the entire flow. Determine the total working time, which is a value added time, and delay, which would be the non-value added time. A process chart is a chart using symbols, time, and distance to provide an objective and structured way to analyze and record all the activities that make up the entire process. A process chart looks something like this. And again, I'll give you a couple moments to review this. Feel free to pause if you'd like. Process chart also looks like this, and you'll notice it shows the operation, which is transport, which is actually moving, what steps require inspecting, where there might be a delay, and when that step is going to storage. An activity chart looks like this, and it pretty much defines which operator does what, when, and how long it should take to do it. A service blueprint is a process analysis technique that lends itself to a focus on the customer and the provider's interaction with the customer. It defines 3 levels of management interaction. Each level has different management issues and identifies all the potential failure points. So a service blueprint looks pretty much like this. Personal greeting. Customer arrives for service, 3 minutes. They get a warm greeting and obtain the service request. And then the next step is it a standard request? Yes, then we go downward. If it's not, then we go over and determine the specifics. Can the service be done, and does the customer approve? Next, if the customer says no, we notify the customer and recommend an alternative provider. The customer leaves, customer pays bill, notify the customer the car is ready. It all depends. If it was yes, we did the work, we prepare the invoice, and we notify the customer. Production technology. There's a bunch of it. There's machine technology, automatic identification system, or RFID, process control, vision systems, robotics, automatic storage and retrieval systems, automated guided vehicles, flexible manufacturing systems, and computer integrated manufacturing. So you can see there's a world of different methods that you can use to produce your product. Machine technology is CNC. It's machinery with its own computer and memory. It gives increased precision, increased productivity, increased flexibility, as you can just adjust the machine to do what you want. You have improved environmental impact. It reduces the changeover time. It has decreased size in where you put it in the location of your layout, and reduced power requirements. AIS and RFID are automatic identification systems used for transforming data into electronic form, for instance, barcodes. RFID is a radio frequency identification, a wireless system in which integrated circuits with antennas send radio waves, and it increases the speed and accuracy of your inventory, your sales, and what you need to order. Process control is the use of information technology to both monitor and control your physical process. It gives you real-time monitoring and a control of those processes. Your sensors collect the data, the measurements translated into digital signals that are sent back to a computer so you can verify and monitor your measuring system. Computer programs analyze the data and report it all back to you in a timely manner. Vision systems combine video cameras and computer technology generally for inspection purposes, and they are consistently accurate. The cameras will actually look to see if a feature is in a certain place or not, or if something's missing. And if it shows something's missing, it will flag and stop the operation. Robotics are flexible machine systems with the ability to hold, move, or grab items, functioning through their various electronic impulses that activate different motors and switches. It performs real monotonous or dangerous tasks, but is consistently accurate and reliable. Automated storage and retrieval systems are computer-controlled warehouses that provide for the automatic placement of parts into and from designated places in the warehouse. So you can look in the computer and know exactly where those parts are in which bay. It's very useful in inventory and test areas of manufacturing firms, and it reduces labor and errors. Flexible manufacturing system enhances flexibility and reduces waste. It can economically produce low volume at higher quality. It's basically a system that uses electronic signals from a central computer to automate your production and your material flow. Computer Integrated Manufacturing, or CIM, is a system that uses CAD, FMS, inventory control, warehousing, and shipping. They're all integrated into one big computer system. And it looks like this. And I'll leave this for you for a moment to study so that you can get an idea of how it operates. Please feel free to pause if needed. I hope you notice the difference in the material flow arrows and the information flows arrows. So, for more information about process layout strategies, see that particular section next. Thank you for viewing today. Hope you have a wonderful day.